Well, good afternoon, everybody. I'm anxious to have this panel discussion. We've got some really power hitters in the industry to discuss kind of what's the new normal going to be like. And but I want to welcome everybody. This is another one of our what we're calling ProTechTalks, and just a little bit about the logistical side. I know a lot of you submitted questions as you signed in, and Buddy is going to be our moderator, and so he's tried to combine those and group them, and so he'll be using some of those. But additionally, if anyone has any questions during the talks, or a panelist says something you would like more information on, use the Q&A, and we'll be monitoring that and passing those on to Buddy, or trying to comment on those as we go. But with that, we'll go ahead and get started. Buddy is going to kick it off by introducing everybody.
Thanks, Dick. We'll also have some polling questions. Did you mention polling questions? I had to jump up for a minute.
No, I messed up there. So throughout the talk, we will be introducing, I think we have 4 different poll questions that we'll put out there. You'll see it show up on your screen. Just answer them, and then we'll give it about a minute or 2, and then we'll share those results with everybody and solicit some maybe feedback from the panelists referencing what the results of the poll were. Thanks, Buddy. Okay,
thanks, Dick. Yeah, I'm pleased to introduce our panelists. It's a very distinguished group. We'll start with Joe Frantz. Joe is currently the president of Frantz and Associates, which is a consulting company in Pennsylvania. He does a lot of technical consulting, a lot of business development consulting currently. He's formerly the vice president of engineering technology with Range Resources in Pittsburgh, and is a Penn State grad in petroleum engineering. Joe, welcome.
Thanks, buddy.
Next up is Brendan Elliot. Brendan is a senior staff completions engineer working in Devon's subsurface engineering team in Oklahoma City. He is a graduate of Texas A&M with a BS in petroleum engineering, and he's currently working on his PhD at the University of Texas while working remotely for Devon, and is a frequent speaker and presenter at SP conferences and workshops. So welcome, Brendan. Thanks for joining us.
Thank you. Happy to be here.
And then we have Nick Steinsberger. Nick began his career with Mitchell Energy in 1988. Oops, shouldn't be mentioning these dates. I didn't do it for the other guy. Sorry, Nick. Nick began his career with Mitchell Energy after graduating from the University of Texas at Austin with a BS in petroleum engineering. He was one of his claims to fame was he was responsible for the first slick water stimulation in the Barnett Shale in 1997, what is referred to as the first modern shale frac. So Nick is kind of the godfather of shale completions as a result. He is currently working with, I think, the managing partner with ValPoint Resources, and he advises INEOS on shale and UK and in other areas. He's been actively involved with some other independents along the way. And he's frequently interviewed by many news organizations, including the well-known presentation entitled The Frackers. So he's one of the frackers that we've all heard about, one of the first to do it in shale. And then last but not least, Dick Leonard. Dick is the Director of Engineering Diagnostics at ProTechnics, a division of Core Lab. Formerly worked for UPR in Fort Worth, and is a UT grad, UT Austin graduate in petroleum engineering. And he's going to be on our panel along with these other 3 folks that we've introduced. So it's a great group, very talkative group. No shortage of dialogue today, I'm quite certain. And like Dick mentioned, we certainly would like to encourage anyone that has other questions. We have quite a few right now, but we will certainly address any others that that you can include on the chat line. So with that, do we want to start with the first poll question, Dick? Or Derek, I should say.
Sure, sure. Derek, you want to put it out there for everybody?
Yep, give me just 1 second, pulling it up now.
Okay.
Coming your way.
So here it is. Is bigger really better right now? Yes or no? Those are your options. So if everybody would please vote. We're going to tabulate the votes later on and report the results for all 4 of the poll questions. Okay. We'll proceed with the first panelist question. And panelists, as we discussed previously, if you have something you would like to share with regard to one of these questions, feel free to wave at me, do some body language, intonation of some sort. We won't ask every panelist every question. So we'll just try to work our way through these questions and we will attempt to cover as many as we can. Most of these questions have been submitted by individuals who registered for this ProTech Talk. So with that, the first poll question is bigger, really better right now. So the question becomes, now that completion diagnostics and completion operations are less expensive, would you be inclined to get the big hammer out and pump more proppant, more fluid, more rate when you complete your wells? So what's your opinion on that? Is bigger really better? Should we take advantage of the cost economics that are in place right now? Who wants to go first?
All
right.
go ahead, guys, if that's all right. So I guess I look at it in a broader context and look at what are the things we can control in our wells, you know, the landing target, the lateral length, the stage spacing, the number of clusters, the number of perfs, all these things we can control. And there's just an unbelievable amount of variables, the well spacing. Now we're doing the wine rack completions and which wells get fractured at what time. And so the question comes back to, have we experimented in the field and done everything possible? Is there other combinations out there that we haven't attempted yet? And so obviously with the prices being lower, it seems like it's a good time to experiment to me, but that's just always been my nature. I've always wanted to experiment. You know, if we're not moving forward, then we're just static or moving backwards. So yeah, I think it'd be a great time. I think the evolution of the brown sand and how inexpensive that was and led us to pump bigger jobs. And I think the industry as a whole kind of went up and ramped up over a certain pound per foot and didn't see the production response. But I'm not sure how much of the plays were really attempted at those higher pounds. But that's just part of the whole puzzle is the fluid in the water, obviously. So, you know, I'll just repeat, I always liked trying new things in the field, as long as we have baseline production that we can match against and make sure that we're you know, centered on what are our real comparisons out there to make the decision, is this better or not? So kind of long-winded answer to it, buddy.
Okay. How about you 3 gentlemen? Is that a good sign? Go.
This is Nick. I voted no on
Nick?
that. I don't think, I think we've tried bigger, biggest. You know, we've tried 3,000 or 4,000 pounds per foot sometimes, and I don't think it's always the sand is, I guess 85% said no, so I was one of those that said no. But I agree with you, Joe, about experimentation is always good. We're continuing to learn. I think we started learning back in the 90s, and we're continuing to do so today. And we've obviously gotten a hell of a lot better than we have way back when I called it the sprinkler fracs we were doing. But I don't think bigger is better. I'm not sure if it's 2,000 pounds per foot or 3,000 or whatever, but I think we've tried to get up to 3,000 or 4,000. I don't think that's necessarily worked. So experimentation, like you said, better targeting, better perf placement, better, you just keep getting better and better at what we know to try, and there'll be new technologies and new things to continue with, I think. But I don't think biggest is best.
Yeah, I'm in that same camp. You know, I don't think bigger ever was better. We just didn't realize we were understimulating, you know, these extremely large intervals that we have in most of these unconventional plays now. And, you know, we've started tapping that with the stagger developments like Joe was mentioning, but never was better. We just realized we can make some more, and we've definitely seen a leveling off over the last few years on overall job size. And, you know, in fact, there's probably some argument to be made that, you know, you have to increase your job just to maintain performance on some of these infill wells, which we've seen in the Delaware Basin, but there is an upper limit on what you can effectively drain and produce. So.
Yeah, I agree. I think we're much more in the optimization mode now of how do we make the same kind of wells with reduced cost. Maybe it's, you know, combining stages, fewer stages along those lines.
What, continue along this line for a bit, what changes would you expect to see? Maybe not larger, bigger. What changes would you expect to see in terms of fluid volumes or cluster spacing, or stage lengths? Are we going to continue to expand the HVFR usage? You know, what sorts of optimization changes do you see on the completion side of things going forward? If not larger, what then?
I would say a more surgical approach as far as, you know, how detailed we actually get in these designs, and how can you start reacting to what you see during the stimulation with stuff like offset pressures and the various other diagnostic technologies we have in the ground. I see, you know, in the near term, at least a lot of people dabbling in this very surgical stage by stage approach to design. And I know, you know, as an organization at Devon, we're definitely looking at that to make that part of our business in the future. So,
Dick, what's the closest spacings you've seen? I mean, I've tried clusters as close as 10 or 12 feet apart, but I don't know how much closer you can get than that.
You know, yeah, I agree. We've seen clusters less than 10 feet apart, and stages not a whole lot more than that. I think we're going to see that probably based on some of the diagnostics that we have shown that we're getting, unlike you mentioned the sprinkler fracs from the beginning, where we didn't get the kind of coverage we want. We left a lot of gaps. I think in general, I see a little bit of a shift to wider spacing, at least not at the 10 foot, maybe back to 15 and 20 foot, and combining stages to where maybe we're doing some 300 foot stages. I think one of the questions I expect will be asked at some point is the concept of extreme limited entry. And I think a lot of people are using that to contact more rock near wellbore and able to maybe do some bigger stages. So.
Yeah, I would agree. Brendan, I like your term of surgical thought as it comes to individual stages, especially where we're dealing with parent-child relationships and not trying to overflood the offset well. But on the question of the cluster space, I mean, at some point, you know, the models predict a lot of stress shadowing and shutting down the width of fractures and screening out fractures. And so that's got to be a consideration. And I know it's different in every rock, but clearly the industry started on really, really big cluster spacing back in the day. Nick, when you were in the Barnett, what was it back then? 500 foot maybe between clusters, 300?
We're all, like I said, sprinkler fracs. We did 2,000 or 3,000 feet in one job, and just put some holes where we thought so, and just let it run.
Right. And then, you know, when I started with range, we were at 300 foot stages, and then eventually went down to 200 or 150 foot. And so everything's just changed, but maybe we've kind of run our limit on how tight we can put spacing between clusters. But Dick, I like the idea, like Paul Whittle, you know, they experimented with doubling the size of some of their frac stages and able to work a deal with the service company to reduce the overall well cost. So those are some pretty clever ideas.
Isn't that just operators trying to take advantage of the poor service companies at a time like this? I'll tell you. Okay, next question. Kind of going along the line of some of the comments that you just made. Talked about fracture interactions. That's obviously a very common discussion topic at the present time. Let me ask you about FDIs. What do you consider to be the most important data point with regard to FDIs? Is it the extent of the communication, or the hit, if you want to call it? Is it the time before the first hit occurs, or the volume before the first hit occurs? Or is it the extent of the pressure hit for the offset well? What do you consider the most crucial factors in determining the extent of the interwell network there? And how would you employ that information on future wells once you had that data in your back pocket?
Brendan, you guys have been doing a lot of good work.
Start
on
with
this
that.
topic.
You and Kyle
Okay.
pontificating on that subject lately.
So we have looked at this a lot in the past, and I'd say just out the gate, if you're not tracking this stuff, you're going to be behind. You have to have a database of how you can characterize this, not only in the time and volume to arrival, but the magnitude, the rate of these increases. Is it the interactions on a parent well, or a monitor stage, or a tow prep? All of these things can be bundled together in this frac driven interaction type bucket. But you can do a lot of things with the time or volume to arrival. We call it the VFR. And then you can take that and extrapolate your diffusive fracture growth rate and your final end of pumping geometry. You can do so much if you just start tracking some simple stuff like the volume to first response. So I would at least start there, but I would really recommend to start tracking everything, and then start building your database, understand your variability as well spacing changes, like completion design changes, because it all matters.
So I think some of the modeling work that's been done out there, especially with ResFrac and looking at the same thing that Brandon was just talking about, and how to incorporate fiber optic data into that, and tensor magnitudes and things like that, and displacement. So there's a lot of advances that are going on towards understanding the FDIs and how are they good or bad. There's a lot of rocks like the Marcellus that the frac hits are typically not good. Then we have some of the oil plays where frac hits are okay or increased production. So it's complicated. I think we're learning a lot in real time on this as people collect better diagnostic data, like Brendan and Elliot, or Brendan and Kyle have been doing. And then I think there's still a long way to go. Some prop to prop interaction may be better than just the water, the created fracture type of approach. So it's growing in its knowledge, and that's part of the experimentation and things that are underway. I think we can still do that type of work under this price environment. A lot of the data that we can collect isn't that expensive, and so we're learning in real time.
Great. Okay, let's shift. Oh, go ahead, Dick.
Well, I just wanted to say, I think one of the things that we've spent a lot of time lately looking at with regards to fracture-driven interaction is, and we've always talked about interwell communication, it being a combination of magnitude, duration, and the directional component. But also, I think a key thing that we've seen is with uneven proppant distribution within a stage, creating some potential superclusters, the potential for thinking it might be a spacing issue rather than a proppant coverage issue can maybe make you make a fault, a wrong decision on that, because I think we assume, and most of the models assume, that we're getting relatively even proppant distribution across a stage. But if you're only going through 2 or 3 of 10 clusters, that fracture geometry is considerably different. So I just wanted to point that out.
Good point. Okay, let's shift gears for a minute. Let's talk about this business of shutting in wells. How about this expression? Should you be cutting back many or shutting in a few? Cut back many, in other words, back off, don't just completely shut them in, a bunch of wells to limit your exposure to the low oil prices, or just shut in a few so you don't take a risk of having some startup problems with those that you do shut in. So cut back many or shut in a few. What makes the most sense to you?
Well, sometimes I think it would be hard to cut back, right? If you're on a ESP or something like that, where you got to be moving a lot of fluid in the Delaware or wherever, it's hard to throttle back an ESP or a gas lift system where you have to keep it unloaded, so you have to inject or have to be pulling so much fluid to keep it moving. So pinching back with a choke or something like that, I think it would be difficult in some instances. And I think, in my opinion, shutting in some shale wells, I think, would be detrimental. You might lose some of your frac network they created, especially some of the early ones you just did. Whereas some other ones, like some of those gas wells, like Marcellus or Utica, might not matter near as much. So I think that's a basin question, specific basin question, not just a general question overall the entire United States.
It'll really be interesting to see the Bakken shut in a lot of production, so is the Permian and the Eagle Ford. And so how many of the wells just come back strong after they're pressured up, because, the matrix pressure is rebuilding into the fracture and you're getting a new burst of life as things repressurize during the shut-in. But, when to shut it in, how much stuff that was in the wellbore did we shove back into the perfs, or do we have any little proppant redistribution near the perforations, or anything, fines migrations or sludge buildup? So it's a grand experiment right now with a whole lot of wells in a lot of different basins. I know, speaking from the Marcellus, we typically didn't have any issues with newer wells, but when you had wells that were still flowing and near their critical point, then you're going to need to install plunger lift and get it kicked off. But by and large, we didn't have too much problem with shutting in wells, as long as we didn't frack into them. If we fracked into them, that was a whole different world. But
Right. Yeah, I agree. In Marcellus and Utica, I don't think it mattered a whole lot, but some of these oil shale plays could be different.
Yeah. Something else just to add on to that, you guys covered the well performance side, but sometimes there's volume commitments and different things you have in different regions of your operations that you'll have to consider for your shut-in planning phases. And you may have to shut in all these wells in this area, but in others you need to keep them going. So your volume commitments, contract pricing, or contract takeaway, everything should also be considered in the shut-in plans.
Yeah, for sure. Mm-hmm.
Okay, you've shut these wells in. Have you been acquiring some data while they were shut in? Have you taken advantage of that opportunity? If so, how are you utilizing those data?
Hope so. It's a great chance to get month or two of buildup data. I know some people balk at the unconventional horizontal well buildup process, but you pair that with your your fracture interference that you saw during the simulation, with the early production life of the well, the child pressure group that Pioneers published on recently, and then all the way to your buildup and then secondary interference tests, essentially. So if you're doing something, if you're collecting data with gauges on your buildup and then your second interference test on these shut-in developments, you can really start developing this timeline of conductive geometry changing. So that's quite interesting if you can collect it and have the foresight to just instrument a few of those wells.
Yeah, I think at Range, we had all our wells with a SCADA system. So every 5 minutes, we got a data point. So no matter if the well's flowing, shut in, short-term disruption due to compressors or whatever. And it's always a good, data gathering exercise, but then someone has to sit back and really analyze that. And with all the shut-in wells, you're going to have engineers sit back and dedicate themselves to trying to figure out, oh, this well's in communication with that well, and it's this degree. And but the data is typically there. I don't know about so much in the oil wells, how much they have the SCADA system on collecting the flowing and shut-in pressures, but in the gas wells, it's more simple, less fluid in the well bores, so you get a better bottom hole response as well.
Okay. All right. We've had these wells shut in. We gathered all this data. We made a commitment. We're going to apply these learnings when we reopen the wells. Now, another question that's come up a lot recently is, okay, you're preparing to reopen some of those shut-in wells. What steps should you be taking before you open them up, and as you open them up? Rates. Are you going to be gentle? Are you going to open up hard? Are you going to try to inject some sort of surfactant or something to help with any potential water blocks? What steps are you going to take as you begin reopening these wells? Nothing? You guys just going to crank them open and step back? Come on now.
Yeah, it's going to be play dependent. It's how they react. You have to understand your field, understand your area. That comes with just the history of operating in that basin. So that's a hard question to answer just in a panel session like this. But
For sure. I don't think for a $35 barrel, I'm going to crank them open no matter what the situation is.
Okay.
I will say we've heard, as wells have started opening in the last couple of weeks, we've heard several people having trouble with producing more sand. So I think it is definitely place specific, and in general, I think oftentimes a little bit slower. I know George King has really preached a really slow back type of approach and gradually bring it on rather than just slamming it open.
And in the Marcellus, we had auto chokes and heated separators. So, you're worried about hydrates if you let it rip. Secondly, the auto choke just kind of takes the human out of the loop. And so when the wells are shut in, then you have a pre-program to bring the well slowly back online. And because you may be bringing on a whole lot of wells during some disruption in the field. So you really have to plan for that. And, a lot of the wells are just gradually brought back on, but gradually maybe a couple days as opposed to weeks.
yeah, I'll just want to go the child pressure group, method. Just be, have a disciplined approach on how you open these wells and monitor the pressure in the other shut-in wells as one comes online, and you can kind of get a understanding of the connectivity between the wells and the magnitude of pressure interference you would expect, and that kind of gives you a better understanding of well performance, and maybe why these wells performed or didn't perform when you first put them on and you didn't do one of these tests. So you can always do these late in life and try to get a better picture for how the wells are connected in the subsurface.
All right.
Hey, buddy, before we do the next question, let's
do a poll question.
Let's have Derek do a poll question for everybody here.
Yeah, buddy, I'll start it now. Then if you want, we can run the poll, and then you can go on to the next question. That way we can give everyone a chance to kind of submit, and then we can come back to it after the question if you want to.
Let's do it.
Perfect.
All right, so the question basically is what camp are you in here with regard to limited entry? Sub-limited entry, we're referring to something obviously less than, say, 1 per minute per perf, or a certain pressure level that you consider below limited entry pressures. All the way up to, I don't really worry about that. Okay. Have those votes in here in a second. You're going to show the results now or later, Derek?
Let's go on with the next question, and at the end of this question, we'll show the results.
Okay, sounds good. All right, change course again here. How has your company been utilizing data analytics? You know, how are you employing data analytics going forward?
At Range, we started probably about 6 years ago focusing on the reservoir group, and we had experimented with a company out of New York, of all places, and they were experts in machine learning system algorithms and had worked in a lot of high-end things, and so they didn't know the oil field, and we spent a couple years with them and found out what it could do in the realm of reservoir engineering and development of type curves and economic programs. And then we went with Novi Labs and have been using them ever since. And so it's been really a good process. It has sped up our ability to integrate various data types from the drilling, geologic completion, the production data, obviously, and build the type curve models. That was a very time-consuming process for the engineers. And unfortunately didn't have enough technicians that would have been doing that. So we took our engineers and they were doing a lot of technician work, which is really, really important work for a technician to do. But so the machine learning system for us was just made all that process so fast, and you could make all these well comparisons with all the different things that we do with different well spacings, different cluster spacings and pounds and landing targets, and just at a push of a button, you'd have all the comparisons that you wanted across the field. So it was really good. And then we kind of took it to a full year's planning program. If you could put in every well you might drill and what options you had for lateral length and for the pounds per well and different well spacings, and try and optimize on your yearly well planning as cash flow, whatever you wanted to optimize on. So for us, it worked well, and we focused really on the reservoir engineers. We had hopes that we would go into the completion group and help them better integrate all that frac data that we get on each stage, and what more could we do with that. The drilling is the same thing, is how could we use the machine learning systems. We did a project with Corba. So I think that you really have to understand what it can do. It's an interpolation method. To me, it's not as much an extrapolation method. If you're going to extrapolate, you still need to build the physical models and still need to go down the what ifs on those, I think. But it definitely has its part in our industry, and I think we're maybe a little bit too much focused on what it can't do versus really what it's good at doing. And so that's a long-winded answer.
Okay.
Yeah, I'll echo that. You know, we do have teams stood up that focus on this topic, and there's been a lot of really easy wins, you know, in the early days. But now I think people are realizing, you know, we actually might need this hybrid approach where you do have some ground truth physics-based models paired up with the analytics workflows. You know, I saw this presentation last week, and we have cameras on our well sites, and some of them have thermal imaging, thermal cameras, and they're using image recognition to determine how full our tanks are at, you know, various times a day. And you can see that through time and as they fill up and when you need to take loads, and then, you know, you can start automating that system. So I thought that was pretty cool, with just, you know, image, you know, thermal color changes in the tank itself. So there's infinite ways to apply it, but, you know, just as an engineer, I always want to echo, have some physics-based, you know, justifications behind it, and don't let the numbers just run out of the black box, but, you know, take an engineered approach.
Right. My dear friend John Applegath used to say about these systems, it's a brutally empirical process. And I'll never forget that. It was, I thought, a very good description.
And I'll comment a little bit about
Go ahead, Dick.
data analytics as far as our diagnostics. It's something that we're have really are in the process of gearing up, and we feel like this is a critical piece that we can help with, in that a lot of the operators have data analytics for the various completion variables, production variables, but oftentimes the diagnostics that have been run aren't really getting put into an analytics. And so we're really spending a lot of time and effort to try to incorporate that into things like, you know, lateral length and pounds of proppant, and what we're seeing in terms of coverage and flow assurance and things like that.
Okay. All right, let me jump over to some of the new chat questions that have been coming in here.
Hey, buddy, before you do that, let's
Okay.
look at the results. Everybody should have it on their screen, but extreme limited entry is the winner, with limited entry being a close second. This is consistent. We've asked this a similar question in several of the other ProTech talks, and extreme limited entry has definitely gained some wide acceptance in the industry over the last 6 months to a year. I know Paul Weddle's been very instrumental in that at Liberty. But I do think it is interesting, and limited entry's been around as long as I've been in the industry and far before that. And it's something that it works. And I think it's, as evidenced by this poll, I think most people think that's something should be very much considered. Any comments from Joe, Nick, or Brendan?
Ooh. However, you can distribute the proppant better than we used to. When we were shooting too many holes and the hole sizes were so big, you know, we had no idea where things going. And we learned about perforation rows, and that was a major new finding not too long ago. And it put things into perspective and a better understanding. So when we're going to all these 10, 12, 15 clusters, you have to have a way to control it. So I think the industry's done a great job, and the tracer work you've done, Dick, and other means to evaluate where did our proppant go shows we're, what, 80% efficient maybe on a 15 cluster job. And that's pretty impressive. So that however we can put the proppant into each of the perforations ideally, and some of them are going to shut down due to, just like I said, stress shadowing, and maybe even some screen outs at the perfs or the toe section doesn't have enough rate to, you know, pump the proppant way down there and they screen out. But it's a pretty quick shift in the industry overall to the extreme limited entry.
Well, speaking of, part of the process is rate, obviously. Another part of the process is the way you perforate the wells. So are you changing your perforating techniques these days? You know, either phasing or number of holes. How does all that fit together with the rate and coming to terms with the optimized completion design?
Yeah, I'll take a stab at that.
Okay.
We're definitely changing the way we perforate versus what we used to do just with the simple 60-degree phase type guns. If you really push the limits on your extreme limited entry, you're going to be targeting multiple thousand PSI delta P. And to do that, sometimes you need to go down to 1 or 2 shots per cluster. And when you do that, you now consider, okay, now what orientation am I shooting at? High side, low side, at the side, those all change drastically. Your hole diameter, it's going to change how the fracture initiates outside the wellbore, your near well tortuosity. All of those things start to come into play when you're only doing 1 or 2 holes. So it's, we've pushed the limits. I think we've gone up to something like 6 barrel a minute per perf in some cases, which is, well into that multi-thousand PSI range. And, the old adage, I think, used to be 2 barrels a minute per perf. So, you really push it, but new things come into play when you start pushing the limits. So I think a lot of people already realize that.
Yeah, what do you constitute extreme limited, Buddy or Dick? Because that question was, like you said, Brendan, that this old story was 2 barrels per minute per perf. What constitutes extreme?
What would you call it? You probably wouldn't base it on rate per perf. You'd probably base it on near wellbore friction pressure. So what's a good cutoff there? 1,500 PSI, 2,000, 2,500 PSI?
Yeah, I think
extreme.
Closer a couple thousand, but I think in a lot of cases we're looking at, in excess of 3, maybe 4 barrels per minute per perf type of thing.
One of the panelists said over 2,000.
Okay, yes. I'm good with that.
Depends on how extreme you are.
I've never heard 6. Is that what you said, Brendan?
That's
You
up.
had 6,000?
That's
6
ultra
barrels
extreme.
per minute per perf.
6 barrel, okay.
Wow.
Triple the old design spec.
Yeah. What size hole is that?
0.37, 0.42. Kind of depends on your guns and how you shoot them and if it's topside or not. We usually go smaller holes.
Hey, buddy, before we go on, I get maybe a follow-up question I would have for the group is, I know we had a period of time in the last couple of years where people were looking at tapered perforating, putting fewer holes at the heel part of a stage to try to get flow to the toe. I'd kind of like to hear what the panelists think about that. I know one of the things we've seen is oftentimes over the course of a job, you might start out with pretty good perf cluster efficiency, but by the end of the job, you might be only going through 2 or 3 clusters, and fairly common that was back at the heel. So what, Joe, Brendan, Nick, what do you think about that?
There's probably more people doing, a standard number of perfs per cluster than there are the opposite. And Brendan, you may be closer, Nick, than I am to it. I don't know. It just throws another uncertainty into the whole equation to me. But I've heard some people have great success with it, but I'm not sure that they have the diagnostic data to really prove it either. So it's all over the map.
I've always been a fan of the tapered, and I actually make it even more tapered as you get towards the heel, because I think your stress shadowing effects are even more prevalent then.
Well, Nick, I was also thinking back 15 years ago, or when we were doing single stage barnets, you were doing a taper to try to get that single stage to treat out near the end of the 3,000-foot lateral. So
Yeah.
Yeah, there's a lot of interesting work on that. At UT they have some model that will do like a taper design, accounting for the proppant inertia and your unequal distribution of proppant and fluid per cluster. So when you do stuff like that, it definitely adds a new level of science to really try to design it from an engineering perspective. So I think that's why Joe said, more people are doing a more standard, design versus a taper design, just because that taper is fairly detailed to actually engineer. So otherwise you're just guessing, 4, 2, 3, 1 or something, so.
Yeah.
Well, speaking of, have any of you run any camera data to take a look at some of these perforating scheme changes and what effect it seems to have on the perforating hole size at the end of a frac stage? Have you seen any conclusions there? I know there are a lot of people that are trying camera data, and there seems to be some frustration levels in trying to understand exactly what those changes in hole size across the stage really mean.
Yeah, EV has some great papers out there, lots and lots and lots of data sets. I haven't digested it to see if I agree with their conclusions, or is this all just random that you're just not going to be able to control? It goes on to a certain extent, but you don't know exactly which clusters are going to happen. But it's great data, right? I mean, anytime you get inside wellbore and you get a look at what's going on through the tracers or through the cameras or fibers, all that stuff, it's fun.
Yeah, there's a lot of people a lot smarter than me were looking at this, and I always see these, and it's scary when you go see those 1.5, 2-inch holes after the fact, and then sometimes we think we can control the design, but in reality we have very little actual control when things are so dynamic downhole. Things run away from you really fast.
Yep, good point.
Yep.
Well, out of respect for the father of XLE, he submitted a question. I'll give him credit for this question. You have any positive experiences with microproppants leading to increased production? Not just being easier to pump into a formation that's hard to treat? Are you really seeing a relationship between the application of the microproppants and increased production?
What are we defining as microproppants, buddy?
200, I guess, 200 mesh proppant, maybe. Would you consider that micro?
200 or smaller?
Yeah.
Yeah, we've talked a lot about this in the last, few years, but we actually just pumped our first job trialing it. So no production results to speak of. But, you can make the case on both sides for the potential benefits or potential drawbacks. I'm on the fence on the science of it all.
It just seems like such a small volume that they pump, and it's pretty expensive. And we looked at it several times over the years and just couldn't pull the trigger. And I'm not so sure it's been tested adequately in the field. I don't know if you had all the wells that have pumped this product, are they 500 wells, are they 100 wells, or 1,000 wells? So theoretically, I can see some benefit, but it's just, I still struggle with how big the fracs are and how many we're growing, yet how few pounds we pump out there. If you're going to pump whatever, 50,000, 100,000 pounds of it, maybe you'd really see a benefit other than just a small amount of it. So I struggle with the application.
And it goes into how you design that experiment. Are you pumping it on enough wells to get a statistical sample? If your production improves 5%, can you prove that wasn't permeability or geology feature that had that increase? So, you have to be careful when you're just pumping stuff in wells, but taking a scientific approach to your design of experiment and trialing things like microproppant or anything that you trial in a stimulation needs to be thought out and not just pumped.
And you've got to do it in a meaningful scale. I mean,
yeah,
it's hard to pull the trigger on a 10-well project, in one geographic area and say, we're going to really give this thing a chance. But, you need a meaningful statistical number, and that's probably 10 or more.
Yeah, once upon a time, when Dick first joined the industry, things like that were considered fluid loss additives.
Yeah.
Yeah.
And now they're
100 mesh.
Remember that.
proppants. Yeah, 100 mesh even, that's right.
And
Okay,
if you
we've
look
been-
at,
Go ahead,
hey,
Dick.
buddy, well, I was
Yeah.
just going to say two things. If you look at, one of the biggest users of microproppants has been, at least that we've heard about, has been EOG, but a lot of that was driven by the fact that they had their own mine and they were able to, it was readily available at no cost to them or very little cost to them. So I think that played into it. And I agree. I remember 100 mesh being a fluid loss. So 200 mesh just, it's always kind of scared me as far as, are you really doing any good? But before you do the next question, buddy, let's do, we got two more poll questions. So let's do one now and then we'll catch
Okay.
one towards the end. Here
All
we
right,
go.
Here we go. Where's our greatest opportunity for optimization here?
You can only pick one.
Yes, sorry.
It's fun.
Hmm.
And then buddy, you can do the next question and then we'll look at the results after these.
Okay.
questions.
All right, we have been toying with this overriding topic of the new normal. So my question to you, now that we've talked about some of these topics that are in the forefront today, what is the new normal? When we come out of this, what's the normal going to look like? How is it going to be different from the past?
Talking about oil price, or what are you talking about?
All of the above. Well, let's just say we have little control over the oil price, but how are our procedures going to be different? Our completion procedures, our production procedures, our artificial lift procedures. Are we going to be more aggressive in the way we complete wells? Are we going to be more cautious and risk adverse? How do you see our philosophy of doing things in the industry as we come out of this slowdown?
Well, I think you look at the gassy companies first. You know, they've gone through this for the last 6 years. And what I saw there was the predominant shift towards longer laterals. And that helped well economics, even at $2.75. And so I think to the extent that the oil plays can do that, it'll help survive at $35, $40, $45. I mean, I just see the oil prices rebounding fairly quickly. There's a lot of world demand for oil and will be, and so if the prices rebound, then you're back to, you know, scrambling for frac fleets. And so I just think that the new normal may not be that different than the old normal, but the gassy companies and what they went through, you know, that would be our benchmark, I think.
Okay.
Yeah, I think from my perspective that, you know, this is just normal for me. I'm a fairly young guy, and it's always been, you know, pretty hard ups and downs. So, you know, I think we just need to keep trying to add value, find these really creative solutions. You know, I think the whole organization should have a pulse on your cost and thinking about optimization. You know, just understand, like, everyone from the techs all the way up the chain to your capital discipline, understanding your balance sheet. You know, why are we spending this money? You know, why are we growing oil or not drilling right now? You know, so just to have a business mind and always be thinking about the next way to save money or make better wells is just gonna have to be the normal. So.
Yeah, and I think I will comment that, you know, both Joe and myself have been through 7 or 8 of these through the years, but this is a different one in that all the others were driven primarily just by price of the product. And this is one where at the same time we have the Saudis and Russian not being able to agree on price, created a hemorrhage, and then you throw in the virus and we shut down the entire world in demand. And that's something we've never seen. I do think that the new normal is going to be continued and probably more price volatility. And I think the companies that are going to really be successful and thrive are going to be the ones that are the most agile and able to adjust quickly, take advantage of things when prices are up, but be positioned to realize, hey, we need to slow down here. So I agree with Brandon. We've been through a lot of these. I just think that kind of like I'm in the camp with Joe, that I think the rebound we're going to see in prices is going to be significant because demand is going to come back. You know, the real question is when, and when it does, I'm really afraid that we're not going to have the supply there. So.
Yeah, the amount of production we've shut in, and we've gone from, I don't know what we were, 800 to 200 drilling rigs, whatever those numbers are for the oil plays. I mean, the declines are so steep, so it'll take us a while to ramp back up and get the production going up. So it's, you know, it's going to be significant for a while for the U.S. And you know, the rest of the world's shut in production, and who knows how long they'll keep it shut in. But at some point they have the capability to turn it right back on, and it'll probably be there for them. And they're, you know, high perm rocks that they're not so worried about. But one other point I did want to make on this topic, I think when you have these downturns, it gives the organization a chance to look at their basic structure. A lot of companies are really siloed. I've got a drilling engineer, completion guy, production guy, reservoir. This may be a chance to merge some of these departments. You have a drilling completion department or a production completion department, and maybe train some people in 2 areas at once. You know, most times you're a drilling guy or you're a completion. At Range, we spent 6 years with all of our new engineers, rotating them amongst 3 or 4 groups, trying to get them better skill sets and cross training. So they're more valuable over the long run. And I think, you know, more layers management we can cut out, the less red tape. And I think structurally companies will be looking at how they do their basic business and a way to streamline it.
I think small companies had been doing that for years, right? But I've heard the Exxons and those companies are actually starting to look at that now. And that's probably the first time they've done that in ever, probably.
Integration, group integration.
Yeah.
Tear down those silos. Sure. Brendan, one of your colleagues is checking up on you here. He wanted to remind you that you guys did 8 microprop wells in the grasslands project in 2012 to 13. Okay.
Before my time, so I apologize. I don't know
You've got an
the history.
So do we have some poll results to show, Derek?
Okay. There you go. Cluster and stage spacing. Clear-cut winners on that one.
Yeah. I'm
Interesting.
glad to see everybody, or most everybody, voted with me. I'm all in on that. Any comments
yeah.
from Joe and the rest of the panelists?
Go ahead.
Not surprising.
No, not for me.
I voted the same way you did, Dick.
Okay, another thing we touched on a minute ago, Brendan touched on a minute ago, and it's a question we ask towards the end of all of these ProTechTalks, as we call them. As a manager or even as a colleague, what skill sets do you feel would be beneficial for us as engineers to devote more personal development time going forward, especially maybe now when things are slow, to enhance our careers? Should we be focusing on technical skills, data analytics, organizational skills, computer skills, soft skills? One of the answers we got from one of the executives at a previous such meeting was he wished that his engineers would devote more time to developing some business acumen. You know, learn how to read a balance sheet, learn how to calculate ROI, you know, so you have a better understanding of what you're doing and how it affects the bottom line. So what do you guys think? If you had your way as a manager, what would you want to encourage your subordinates to spend more time on, or what do you feel like you should spend more time on?
So I'll take a stab at that. You know, just being a technical guy and looking at a lot of these new things coming out in the last few years in the realm of diagnostics. Everything's in a different type of, you know, data format, data structure, file format. So you really have to be fast and, you know, almost able to make your own tools, to make your own viewers, to pull in some fiber optic data, to pull in the microseismic data, to pull in your tracer data, to pull in your sealed well responses, your pressure monitoring, and like kind of develop this whole theory of what, you know, what's going on. So I would say, you know, understanding data structures, having a basic level of coding like Python, MATLAB, something like that. That'll just make you faster and more dangerous. And you can always sprinkle in data analytics there. But, you know, that's where I see, obviously, besides the soft skills, that's critical. You know, you have to be able to not only do the work, but also tell that story and convince people, you know, what's going on, or to propose ideas and have people trust your opinions and your engineering analysis. So, but with the way data is structured now and how much is coming into our shop, you have to be fast and aggressive at manipulating it to get your value. So.
Well said.
I would agree, Brendan. I mean, when I got to work with all our different departments at Range, and so for all the engineers, obviously you have to be good technically, right? That goes without saying. But the relational databases and learning at least Spotfire or something broader in machine learning systems now, being a data analytics, learning your economics and being able to run whatever, some reserve program in Aries or something to make comparisons between wells. You know, those are some of the differentiators that we used to look for, and people that were willing to, in their career, to learn something outside their main domain You could see they're more aggressive. They just had a broader passion for learning. And then the soft skills, you know, the younger generation, they love the computer side, and less so to walk down the office and sit in front of a person. You know, they'd rather sit there for 10 minutes maybe and type a nice long email than go down and have a 10-minute conversation. So that was something we really pushed, you know, get out of your office, go visit people. And just be a good communicator, you know, put presentations together. We used to always have the folks give impromptu little presentations, and you know, that's what it's all about, is the people that I think really succeed are the ones that communicate, and that they can carry on all their interpersonal relationships like this. And that's, our industry is so great for that. And I'm so anxious for conferences to start up again, because just love seeing all my buddies and spending some time with them. So yeah, it's a lot. It's a lot to put on a young person, that's for sure.
Points.
Yeah, I agree. I think communications is huge, and it'll even be more so going from the years to come.
Okay, let's deal with a few esoteric technical issues here that have been brought up. Some things that individuals are concerned about. Not everyone may be practicing some of these techniques. One question that's been asked is, what diagnostics or metrics are you employing to assess re-stimulation candidates? If you're looking to try to decide, you know, right now I don't want to drill any new wells, I want to maybe re-stimulate, use my funds a little bit more selectively. So what sort of diagnostics or metrics would you employ to make those re-stimulation candidate selection? Come on, it's not just a dartboard and throwing darts at the dartboard.
Go ahead, Brandon.
I'm a big, you know, depletion mitigation proponent. So one of the first things I'm going to look at is, do you have offset developments coming up near these wells, near this unit? And if you do, you know, look at that parent well's production history, and it may be a very prime opportunity to refrac that well as you come in and infill and complete the infill wells or the new wells. So that's one of my main things. If you're doing standalones, you know, the obvious answer is look for the understimulated wells, look for the ones that had, you know, the 2014 vintage type completion on it, you know, look for bypass pay, the low hanging fruit. It's going to be difficult to re-stimulate some of these newer vintage wells, in my opinion, and really get, you know, some uplift on the already aggressive wells. But we know we're leaving stuff behind, so there's always going to be opportunities there in the future. It's just going to be a cost balance.
Yeah, I agree, Brendan. I think it's going to be very difficult to frac some of these new wells. How do you refrac a well that's got thousands of perfs in it that are 10 feet apart already, right? I mean, Devon's got the most refracs of probably any company, because of all those Barnett wells that I screwed up a long time ago that you guys are coming back and refracking now. But they, you know, but yeah, we were fracking 500-foot spacings. Now you're fracking 150-foot spacings with 15 perf clusters in there. So yeah, I think the older wells for sure.
I think they've had some pretty good success in certain areas of the Eagle Ford, and they were with old style completions. And that's been really impressive to see what's going on down there, and running the inner sleeves and fracking the plug and perf again. And, you know, originally when the industry just started pumping down the casing of the old well and trying to use diverters, it just had limited success. And, you know, to be able to isolate and perforate new holes, that's the key. But like you guys said, in the more modern wells, we have perf clusters every 15 to 30 feet. So do you really think we can go back into those wells? Probably not. But if you have 50 foot or more perf spacing, maybe that's a candidate.
Right. Dick, how much? I think the Haynesville SM had some huge success about refracs, right? I've never done any of those, but what do you say about that, Dick? There's been some big successes there.
I think you know, each of the basins, and I would say it's very much basin specific. Haynesville's had some success at times. Obviously, it's got a higher pressure environment that you're working with, which sometimes works for you, but sometimes works against you. The cost of the refracts are higher. I know Bakken refracts historically have been pretty profitable. Those of you who know me, I'm a big believer in refracts. Not that you did it wrong back when you did the Barnetts, Nick, but I think just the evolution in all of the basins and completion designs, and there's thousands and thousands of wells that were completed in I will say suboptimal. Now, whether or not they ultimately can justify a refrac, I 100% agree with Brendan that coupled with fracture-driven interaction, I think that could be a plus, because then you don't necessarily need a significant uptick in that refrac. You're kind of getting a dual purpose. You're trying to help on your infill development, but also maybe get some increase. So I do think it's play specific, and even within a play, some areas are going to work better than others. Let's do the last poll question before we go on to another question, buddy.
Okay.
Here it is.
So where's this biggest technology change happening as we come out of this period we're in here?
And then, buddy, you can ask another question, and then we'll show the results after the responses to them.
We might have to screen these results, Dick. Make sure that last one doesn't get too few votes. Might have to throw out the highs and lows or something. Okay, here's another sort of esoteric question, and it's a continuation of some of the things we've talked about before. Okay, you want to do a refrac, and you want to do it in a well that has a low pressure thief zone, and you don't have an opportunity to set a liner and isolate that zone, so you're going to have to deal with it. So the question from this individual is, how do you plug off that low pressure thief zone or eliminate its effects without a liner when you go to refrac that well? How are you going to go about this?
Pray.
Are we getting paid for this?
Without a liner.
I think I've seen a lot of success with maybe like a pre-charge on that zone. So it's going to be a low pressure zone. Go ahead and pump some fluid in at a low rate to do a little pre-stimulation on that, and then go hit it full force. So that's kind of a concept that a lot of people have published on already. But we know we have bias drainage, and we know we have maybe some thief zones or natural features that are low pressure. But any attempt to equalize your pressure before you start your refrac is going to help the overall distribution of the said refrac. So that's maybe my simple answer without knowing other details, but and without spending too much money. But
all right, I'll tell you an answer for that one. Back in my pumping service company days, the Western Company, we had a product called high friction gel.
Mm-hmm.
Basically, it was a very high viscosity, like a 60-pound cross-link gel with no breaker. And you pump that into these thief zones and let it thicken up real good. And we had some pretty good success not losing fluid to that thief zone. It may not work in all cases, but I actually saw somebody in a technical blurb recently talking about a similar concept, pumping something of a high viscosity nature into those thief zones to seal them off temporarily.
I hope that wasn't a protective thief zone, because you pump 60-pound gel into that, and it might not ever come back.
Well, that's pretty much it. That's pretty much the assumption you're making. I mean, it'll break down eventually, but maybe not in your lifetime.
That's why Buddy's not there anymore.
Well, it sounded like it. It
That was
looked good.
5 years ago too, though. That was
Let's
a long
show the
time.
results of
All right, we're going to go over all the results here. Okay.
let's show
The analytics. Wow.
here we go.
We're winner.
Data analytics. No surprise there.
Looks like there's not
And
much.
I think we've already touched a little bit on that.
Not much of a future for drilling improvements, doesn't look like.
They've come tremendous ways in the last years, though. I mean, drilling
That's
the,
exactly right.
Yeah, that's true.
drilling these horizontal
Any other
wells in 10 days now or less. I mean, they're just unbelievable. I would never have believed that 10 years ago. So
Any surprises here, panelists, with these results? Anything rated lower than you expected?
Not really. Little time check, buddy. We've got about 15 minutes, a little less than 15 minutes. So time for a couple more questions. And I don't know if there's any in the Q&A that haven't been already addressed. We've kind of
I
touched
think
on
we've
some of them. But
covered most of the chat questions that have come in. Okay.
Going back to that refrac question, I'd like to know what diagnostics the gentleman had that he knew he had a thief zone and at what depth, and how did we know that?
He didn't share that, so
Yeah.
all right. Okay, couple of gas questions. I told you these were going to come up, Joe.
I'm ready.
Well, maybe you may not be the right one to ask the question, but what do all of you gentlemen see as your company's position on gas assets going forward? Are you going to, obviously, Range Resources is a gas player, so we expect that not to change much, but any of you, your organization is going to put more emphasis on gas, or still stick pretty much with your oil to gas asset ratio?
Well, I still have Range stock, so I'm rooting for Range. Go
Okay.
Range. And,
Right.
you know, a lot of the gassy companies, they've had a great run here. The strip price next year, I think, is still looking more favorable than it is the last year or so. You know, the oil companies, you know, will they diversify and they'll want to go into Appalachia or Haynesville because there's, you know, a gazillion wells left to drill yet. And if some of these newer pipelines get in, then you've got increased pipeline capacity. Of course, the Haynesville's trying to get their gas down into the LNG spots, as is Appalachia. So I don't know. I think there's a good upside for the gassy stocks over the next couple of years. I mean, we've gone through 5 or 6 really tough years. And as long as the LNG can grow, as long as there's more demand in the U.S. for natural gas, you know, we've grown a lot through power generation, but we can never get a pipeline through New York. You're going to touch it all up through the Northeast states, which are just crying for natural gas. But you got to get through New York. And once that happens, I think then you'll really see a big run on natural gas.
Okay.
That's above my pay grade, so I can't really speak to that.
Oh, come on. You got to have an opinion anyway. All right, Joe, one more question that I promised you earlier. And this is another question that came in from one of the attendees. What's the latest in Upper Marcellus well spacing optimization? This individual wanted to know.
So the Upper Marcellus, I'm not quite sure if we're just saying Marcellus in general or we're saying some formations above the Marcellus, but I'll just say it's the Marcellus in general. You know, the well spacing has gone anywhere from 500 foot up to 1,000, maybe 1,100 foot in some cases back in the day. And I think folks have settled in on somewhere around 750 foot. You know, there were some really thin areas down in West Virginia where folks were putting in wells really tight spacing, 660 foot or even less. And that always amazed me, but boy, those wells have a really, really high recovery factor. Those are really tremendous wells. So it's hard to fault what they did. When I started at Range, we had a couple of pilots of 500 footers, and we used that to benchmark against our 1,000. And, you know, we wrote some good papers on some of this stuff through the years. But I think settling on 750 seems to be about the right spot. But there's still going to be a lot of 1,000 footers that you might try going in 500 foot infills at some point, and different landing targets. At one point, we were happy with one zone and then we went to another zone. So there's a lot of upside still in the old range acreage that I know, a lot of upside. Yeah, I think, Buddy, the typical right now is 660 to 1,000. And in the northeast part of the play, you could have two different zones. The Marcellus is really thick, and I know some groups have experimented with an upper part of the Marcellus and then a lower part. So eventually it could be a wine rack design. But as the drilling slowed down, then they just focused on the bread and butter and stand lower. But at some point, I think they're going to go and experiment and go higher as well.
Joe, we had a bunch of Marcellus stuff down by you. We had a lot of problems getting zipper fracks away. We're 500 or 600 feet apart. They were just very difficult to frack. I don't know if you had that same problem or not, but we were forced to spread out those a little bit more than the 500 or 600 feet just to get sand, fluid and sand away.
Yeah, we didn't do very many of the 500 footers. There's one pad I recall we did have some issues, but we still had our perf clusters pretty far apart, so I know it wasn't a stress shadowing issue. But yeah, for the most part, the Marcellus, treats okay. I won't say it treats great because there are a fair number of wells where you're pulling your hair out trying to understand what's going on in one stage or two stages out of a wellbore. And that's probably every play that happens. But yeah, I agree with you. I think conceptually, the tighter you go in your well spacing, and as you're adding more perfs, you're gonna get into resistance issues.
Hey, Buddy, I'll comment in general with regards to something that Joe brought up. I think one of the key things, and it maybe should have been included as one of the potential answers in the previous poll question, but I think target selection, we're going to see a lot of work over the next 6 months to a year as we're coming out of this downturn in high grading the targets, looking for multiple targets. If you just look at the Permian Basin where you've got 3,000 or 4,000 feet of rock, they have a ton to work with. Joe was dealing with the Marcellus where you might have 300 or 400 feet, but I think we're going to see a lot of the not only optimizing on the clusters and stage spacing, but also where we're targeting maybe more significant wine rack adjustments.
Okay. Crystal ball time. We're fixing to wind down here. We need to go over the poll results and see if we have any other conclusions regarding the poll results. What do you see as the most promising oil field technology on the near horizon? Any particular area, and then in particular on the completion side, what do you see as the most promising completion-oriented technology on the horizon? So overall oil industry, 1, and completion side of things, number 2. What are the most promising technologies?
This is a core lab thing, so we're going to say tracer, right?
Okay, we got your vote. Who's next?
And core, we need more core.
Okay, got your vote. Brendan, how about perforating? Owen? No, go ahead.
No, definitely we need to get better at that and how we're doing that. But as a whole, I would say, fiber needs to be cheaper to be more accessible because there's immense learnings from that. But completion specific, many of y'all know that we've developed the sealed well technology, monitoring the kind of the pulse of the well in the subsurface. As you see fractures passing the sealed well, you can make tons and tons of interpretations and analysis on those signals. It's a known point in space. It's really powerful moving forward. So obviously, in my opinion, we helped develop it. So I'm going to vote for that.
I think that's one of the most creative things I've seen in years. So you guys did a great job on that. And then the benchmarking was really, it was necessary, and you did a great job. So congrats.
Thank you. There's a big team at Devon working on it. So we have a lot of people to thank for that.
What do you think, Dick?
Well, I'll just make a comment. I think a key piece, and this is something that, there's been a lot of different diagnostic work, obviously, that we've been involved in, other companies, microseismic, cameras, et cetera. I think a key piece is in the integration of various diagnostics. I don't think there's really any diagnostic out there that answers all of the questions. I think where we can get a good agreement, whether it's between tracers and cameras or et cetera, I think really allows us to high grade. And so I kind of see the next 6 months, and maybe product prices bounce back enough, and maybe it's not like your first question, bigger is better, but maybe we do a few science wells where we're really trying some different things within a single wellbore, and looking at various diagnostics and looking for those places where the diagnostics from different technologies agree, gives us much more confidence in our decisions.
Yeah, so I'll throw out two things. One, I agree completely with what you said, Dick. To integrate all the data and to put it together and interpret the production data. At the end of the day, that's what you're going to do, right? That's your longest data points. You're going to be history matching data, and coupled with that, you've got your hydraulic fracture side and all your static G&G model in there. But to be able then to take that model and say, well, this is the new completion we should use. It's all about, like Ray Walker, my old boss, he said, well, yeah, we can collect this data, but then what are we going to change? Where are we headed with this? So that's the first key point, is what do I want to change in the field? And so I think one of the newest things to integrate all that, the ResFrac model is very, very good at integrating and doing the frac job, the flow back, and then the long-term production. It's really a revolutionary product. And the ability now to look at the fiber strain data that some companies are collecting and be able to monitor that, to use the frac model to look at and match the fiber optic strain data is a huge advance for the industry. And we're learning a lot about how fast fractures grow and what the geometry looks like. And then the second one, I think as the industry's gone towards longer laterals and we've grown beyond the reach of coil, then we needed something different. So we went to the snubbing units, the stick pipe and the standalone. The best system out there is probably the standalone rigless snubbing units from Deep Well, the hydraulic completion units. And there'll be some papers coming out about that with a couple operators here in the next year. But the ability to drill frac plugs beyond 10, 12, 15, 18,000 foot laterals and consistently drill them out and not worry about getting stuck, that's such an important part. We don't talk about drilling out frac plugs very often because it just happens, right? A couple days and they're out. But when you're going out 18,000 feet in a lateral, which they do in Appalachia, they have, and the average range well last year, I think, was maybe 14,000 feet. So it's real critical that you can get in and out of the hole and not get stuck. So that's kind of my two advancements that I've seen.
I agree with you. One thing I'd like to see us do is make some real-time decisions with our data, as we go, make some changes in the process. Okay, we got too fast to hit on the offset well. Let's do something then, not wait till the next well. Do we drop far field diverters? I don't know, something. Let's get aggressive and let's try to get more out of that well instead of just making that well a learning process for the next well. Well, folks, panelists, Derek, everyone that's participated here, we thank you so very much for your time, your insights. We probably would have paid you thousands of dollars to come and share all these insights with us. We appreciate you doing it for free. So, so you guys are a real asset to the industry.
Buddy,
What's that?
Let me give you my Caribbean account number.
Buddy will be sending each of the panelists a check.
No, we really do appreciate it. We've got.
I do want to.
I think the beauty of this panel is we got the wisdom of the past, and we've got the education. Assuming Brandon makes the cut down there at UT, I'm sure he will. So good luck on that, Brandon. Good luck on the rest of you and all your future undertakings. And my last parting question is, when are we going to hit $50 a barrel oil? By the end of the year or not?
Definitely.
For sure, end of the year. Dick Leonard says August.
All right. Brendan, end of the year, fourth quarter?
It'll go up, it'll go back down, but it'll be sustained next year.
We're going to make 50 this year, though.
Yeah, we'll pop through.
I agree with that. I think we'll hit 50 this year. I don't know if it'll be August, but we'll hit 50.
There you go. All right, we're all leaving on an optimistic note now. So thanks again. Thanks you for all the attendees, for your chat questions, and spending the time with us. And we wish everybody the best of luck. Stay safe, stay well. And we'll probably have another ProTech Talk next month. So stay tuned.
All right.
Take care, folks.
Thank
Bye,
you.
everybody.
Thanks, Nick, Brandon.
Thank
Really
you.
appreciate it.
Thanks, guys.
Yeah,
Thanks,
thanks, guys.
everybody.
It was an honor. Appreciate it.
Thank you. Appreciate you joining us.
Time to go to the beach.